Welcome to the second video on stroke prediction problem. In this video, we will go a step ahead with our project. So far, we have performed data pre-processing on our data sets. We have cleaned up our data set. Moreover, apart from that, we have converted all of the string type into a numeric data type for the model creation. Without any further ado, let's get started. One of the key aspects of this machine learning is model evaluation on validation. In this video, we will be focusing more upon that. Now, before starting on that, I'll give a brief idea of what are the algorithms we have used. So under the category of supervised classifier algorithms, we have used three algorithms for this stroke prediction problem. The first one is the Gaussian naive Bayes, followed by decision tree and random forest. Okay, so for the model creation, we have to group this data in the two subsets. The first one is the X features and the Y features. So in the X features, all of these 11 features are X features. As you can see, gender, ever married, work type, residence type, smoking status, age, hypertension, heart disease, average glucose level, body mass index, all of these are X features, which means they are independent features. And the stroke column is the dependent feature, which is Y feature. So we have to separate them for our model creation. So in the X train, I got rid of all of these Y feature or the last column, which is the stroke column. So if I'm using this axis equals to 1, it means I'm dropping off or chopping off this Y column. So let's look at the shape now. As you can see, the shape is now the same with 11 features. The 12th feature got waved off. Followed by the Y train, we will keep all of this Y feature, which is the stroke. The only one column of this Y feature is stroke. So hence you can see you're getting the shape of only this much, right? Now, as we all know that there is one important thing which has to be maintained before feeding everything to our model. That is called train test split. Hence, for this reason, we have splitted our data set into training and testing. Now, under these two subsets, which is train and test, in the train subset, we have created a further subtest, which is X train, Y train. And further with the test one, we have done the same Y train and Y test. Okay, so we have imported this train test split from this sklearn library. Okay, now this train test split function have been used to feed this X train and Y train data sets. Okay, and from there we will be returning all of these four arrays: X train, X test, Y train and Y test. All right, so let's quickly look at the shape of these X test and Y test. So hence we will be returning this number of records from this X test and Y test. You can also check the head of X train, and here you won't get this stroke column because earlier we have chopped this column. Followed by the Y train, you will only be able to see this much of records, the stroke records. Okay, this X test goes like this, and similarly Y test. So we have now perfectly created or perfectly divided into X train and Y train. Okay, now this is very much essential because the train is used to fit the model and test is used to evaluate the model. So we will look now with the fitting of model. So as I've said earlier, we will be using three algorithms and from this sklearn library. The first algorithm is Gaussian naive Bayes. So in order to get started, I have quickly imported it from the sklearn library. Now, after this, we have created the object of Gaussian naive Bayes. this object has been created. Now we have used this fit method, which takes the training data as argument. See, as you can see, this X train and Y train, both of these are training data. So we have kept them as parameters in this fit method. Okay, so now all of these are taken. The second function which we have used is predict function to predict the labels of testing data sets based on the values predicted from the Gaussian model. So here we are getting an array of this predictions. So basically what does this predict function does? It predicts with respect to the predictions on the testing data. Up next, we have used this score function, which takes the feature of X test and Y test. Y test is nothing but the expected target values. Okay, so one is the predicted ones, the X test is the predicted ones, and the another one is the target value. So one is the ideal value and one is the real value. So based on these things, the real values and the targeted values, we will look our performance. That is the evaluation, how much we are able to do with the prediction. So as you can see, we are getting this 97% accuracy after this using this score method. So hence we can conclude that naive Bayes gives us 97% accuracy on this stroke 1. Okay, followed by this, so we are up with the second algorithm, which is decision tree classifier. So again, the same thing goes on. We will be using this sklearn library. We will be creating the object. We'll use the fit function, predict function, and the score function to do the same as we have done previously while in the naive Bayes. So here you will be getting an accuracy of 96%, which is less compared to this naive Bayes. So naive Bayes is performing way better than this decision tree classifier. Now we'll go to the third algorithm of the supervised machine learning, which is the random forest classifier. Now in this random forest classifier, similarly, we have created one object with the help of RF, and then we have used this fit function, predict function, and score function. Both of these methods used for fitting and predicting our output. Here there is another thing which you will see, which is n estimators. So n estimator is a parameter which I'm passing to this random forest classifier object, which means that how much number of trees I want to make. Okay, so as you know, there is a hidden way of using this algorithm, which I will be discussing in the next class, how these algorithms actually work. So this n estimators is nothing but it is specifying how much number of trees I do want in my random forest classifier, which is 100. Then similarly, I have performed all of these things, all of these three methods, and after performing, we're getting an accuracy of 98%, which outperforms all of this previous algorithms. Like this performance of this random forest is outstanding, which is 98%. I hope everything is clear to you right now. In the next video, we will look, or in the upcoming videos or in the upcoming projects, we will look more on this prediction, all of these prediction methods, which is confusion matrix, precision, recall, F1 score. Till then, stay tuned. I hope you liked my video, and yes, thank you for being patient.